Alright, so as we're talking about water, we're talking about surface water. We talked about the fact that surface water makes up basically less than 0.3% of the 3% of fresh water. And when we think about surface water, it immediately occurs after precipitation. And so one of the key features of surface water is something called runoff. Who can explain to me what runoff is?
It goes, like, after it rains, it goes down, like, not clouds and just runs off to the soil.
Follows the slope of the land, right?
Yeah.
It runs right down the top of the ground. So that's basically what runoff is. Okay, so it's basically water flowing down the slope. Now that water eventually has to get somewhere. So where does it go?
Well,
That's a whole different process. But we're talking about runoff.
like in the water, like in the water.
Into bodies of water, right? We call those bodies of water storage. So when you think about runoff, your runoff is going to go basically to the lowest area. So if you're looking at a topographical map, the lowest elevation is where that water is going to collect. And again, we can call those storage areas. Now, you can almost think of it as all water runs to the ocean. Eventually, it'll get there, but it's not always going to get there straight away. So collectively, we call all these basins storage. So we have storage right here in the oceans. We have storage as in a lake or any kind of reservoir. And then again, if you have a river, right through here's a little river, that's also storage. By all technicality, a puddle would be a storage, yes. If we want to go down to that scale, yes, that would be storage. All right, so that's basically what I want you guys to understand. When water's running off down the slope, it will run off until it hits the lowest elevation, and then it will start to pool together. And that basically becomes your storage. One thing that we'll talk about on Monday when we talk about stream development is the groundwater. The level of a stream, not immediately after a rainstorm, but just the average level of the stream, that actually represents something we call the water table. And it's super saturated soil. Right? Think about the soil as a sponge. And so the water has completely filled all the pore spaces of the soil, and that's actually what feeds the river. So the river's not fed from the bottom of the channel, it's actually fed from the top of the water. Okay, so wherever that water is, the level of the river, that's what's feeding, that's where your water table is. And then the same thing with lakes and oceans. Again, you can see how this water table goes right to the same level of the ocean. So all of that's going to be level with your water table. So let's say that you build a lake house. And you think that, hey, here's a really good idea. I want a basement in the lake house. All right? Why is that stupid? Exactly. As soon as you break ground, about 3 or 4 feet under that ground, you're going to hit the water table. And all that water is going to come gushing in.
We have a basement, and ours is like flooded all the time.
Garrett has a very, very low water table, which means that it sits like right there at the top of the soil.
Wasn't Garrett like a swamp or something?
Exactly. So Garrett floods really, really easy. So you're not alone. If you talk to people around town that have basements, almost all of them are unable to use their basement for anything.
My basement doesn't flood.
There's a lot that do though. So again, depending on where you're at,
My cousin had a really nice basement, and it's just like a month later.
yep. So that's what, you'll see that a lot in our region here where you have a lot of homes that are being flooded. All right, so I want to talk about runoff, right? Runoff is kind of a bad thing because what it does is it erodes the land. Okay, and while for most of us in this room, we're probably like, okay, so what? So it erodes, right? But you know, again, we live in a farming community. What's the problem with erosion? Why is that such a bad thing? Yeah, you got, think about 2 years ago, right? We had those really heavy rains and people lost huge percentages of their crops. They were just basically swamped from the water. So in that case, we had really bad runoff. And that's something else we'll kind of talk about this unit. We talk about soil. We'll talk about interaction in the next minute. The type of soil affects runoff as well. So when we think about runoff, you really want to kind of control the amount of runoff, get it to be nice and gentle. You don't want a lot of fast runoff. Bad things can happen when that occurs. But vegetation is probably the most immediate part that really helps us to control the runoff. Saw the demonstration, right? The vegetation, it acts as a roadblock, and every single time that the water hits that piece of vegetation, that plant, the tree, the shrub, the grass, it slows it down, it deflects it, and as long as water is moving slower, then it erodes less. So what you really are trying to do when you're trying to limit the amount of runoff is you really need to slow down the water. Okay? If you've ever noticed, especially in a lot of built-up areas, you will have kind of like this. They have this cement, like angled slope right down here, and then you usually have this ditch that kind of comes in like this. That's all cement lined, and then they start putting up these big, huge cement blocks. And the whole point of that is so that when the water comes in, water comes down the channel, it's going to hit this and deflect it off, and it really slows down the amount of water flow that's coming down that cascade. And that's the whole point. You're trying to reduce the amount of runoff. The best way to do it, again, if you have a hill that's starting to show a lot of erosion, best way to solidify that is by vegetation. And if you're talking about a riverside, like a river bank, one of the best ways to shore up the river bank is to plant shrubs. And if you're doing it really well, you can plant English shrubbery. If you don't get that, you're no longer cool. I think I just lost a whole bunch of people. Okay. Rate of precipitation. Why would that be an issue?
Because rain can give off a lot of water.
Yeah.
Say the obvious.
Yeah, a little. Okay. So obviously, right, if we're having a heavy downpour, you're going to have a lot of runoff. Okay, we're getting a little bit of sprinkle, we're not really getting a lot of runoff. Ladies in the front, just close your laptops and pay attention. Thank you. One of the things we also said was this thing called soil. That definitely affects our runoff as well. And what I want you to notice here, take a look at the difference between A and B. What do you guys notice? Yeah, what does that mean? Yeah, we have a more compacted soil on B than we do in A. So imagine your water coming in, as it's raining, and I hit here. Where's my water going to go? So go around, and then I'm able to kind of snake my way down into the soil. So I'm able to infiltrate fairly easily with what we call loosely compacted soil. So this is loosely compacted. Or poorly sorted. But on B, we have a very high compacted soil, and so there's nowhere for the water to go, so what does it do? It just runs off down the slope. Now this is really kind of, I want to make sure you guys are making this connection here, because when we talk about the types of soils, especially in our region, there is a type of soil that prevents the water from being able to go into the ground. What is it? Not concrete, that's not soil. And I guarantee you the majority of your homes, especially if you're out in the country, probably have this as your main soil.
No.
No, that's terrain.
Oh.
Not sand. Clay.
She said.
Oh, I didn't hear that, sorry. All I heard was the cement from that side of the room. So clay, and that's really an important thing. When we live in a clay area, we have a lot of flooding. So when we think about a lot of the farm fields that got flooded a couple of years ago, that immediately tells me that the majority of our farm fields around here have clay as their main soil. And you can actually grow a lot of stuff in the clay. It's a little bit harder. But the one thing that clay does is it basically, it prevents the water from flowing. Okay. You guys remember working clay in your art class?
No. Not yet.
Not yet. Okay. So when clay gets wet, you actually start off with, if you ever seen like dried clay, it's really cracked and it kind of occurs in these little circles. Some of them are almost polygon in shape. Okay, so that's dry clay. But when it gets wet, the individual clay pieces absorb the water. So some of the water does get trapped into the clay, but when it absorbs it, then what happens is now my clay expands and they overlap. Very much like your shingles on your roof. And so then as new water's coming in, there's no pore spaces for that water to go into the clay. And therefore, it either runs off very quickly, or if you're in a flat area, it just starts to fill up. So again, the type of soil that we have dictates the amount of runoff we have as well. So those are some of your three main factors there. Another one I want to talk about is slope. We're actually going to model this one here in a minute. So what is slope? Rise over run. It is such a simple concept. I had no idea why I do not do a great job at getting my students to understand how to do slope in math. So it's rise over the run. Vertical change over your horizontal change.
Yeah, we're doing that right now.
Great. It's your vertical change over your horizontal change. Delta Y over delta X. Okay, so let's model this for a minute. And we'll come back to this. If we have a steep slope, we have high runoff. And then we also have low infiltration. And then if we just lower that slope just a little bit, we completely reverse this. We have high infiltration. With low runoff.